In this video, I'm having a conversation with Cisco partner called Worldwide Technology. They're able to take the data that you have available from the field and from many other sources to deliver business value. Here's the discussion I had with Matt Nalbone, the energy expert at WWT.
So Matthew Nalbone, I work with WWT or Worldwide Technology, as some of you may be familiar. I was previously at Cisco in the Industry Solutions Group, part of the IT sales group, always supporting oil and gas. But then I moved over to WWT as part of being an industry advisor, client executive for our oil and gas customers, and supporting the internal client teams for our oil and gas endeavors.
Awesome.
So go ahead. Oh, that's you're asking me something, Roland.
Yeah, well, I was going to.
Okay.
So talk us through a little bit about kind of how you have this conversation with customers and kind of where do we start?
Yeah. So, I mean, the interesting thing, like you pointed out, we had Kevin there talking about all the sensors that can be deployed and the flexibility of LoRaWAN and how easy it is to get new data points. I mean, all of this that you're talking about today, from the carbon capture all the way through, anything sustainability, there's always new data, right? And a lot of the customers, they have these one-off projects that are driven by different business groups or business units within their organization, and none of them have a consistent way of looking at all this data and how they're going to be ingesting it. So that's one of the biggest problems, because it's so fragmented within these organizations. So helping them kind of decide of what direction they're going to put this, obviously that's the boil the ocean question, but at the same time you have to have visibility into what that big picture is, because without, you don't have a clear purpose of what you're doing with all the data, right? All the data is being created just for being data, right? And any data that's not analyzed, well, that's just data, right? You can't really do much with it. There's no value. So that's one of the biggest things. And then once you're able to have at least some kind of vision, at least a direction, right? It doesn't have to be necessarily a goal, right? We want to be X. You don't have to have that. We just need to know what we're trying to do. Transformation. What does that really mean? How are we trying to get there? That's the kind of the definition of, our overarching objective. And then,
So a lot of times customers don't necessarily know what the answer is. They just know they've got an issue here, and then as you talk through it, it kind of iterates into a solution. Is that fair to say?
yes, and I think the danger of some of that, though, is that there's no one size fits all solution either, right?
Nope.
So it's being able to have a consistent methodology and how you're applying it to these things really make a difference.
Very cool. Well, I want to dive right into a model that you introduced me to a little while ago that actually maps out kind of what does a data solution look like. Can you take us through this model, and then maybe talk us through kind of where the value sits with a customer and how you get to that definition, and then we'll dive into a few examples.
Yeah, and coming in on the heels of Kevin's presentation, this is really good because he had it, laid out in the technology perspective of where those sensors fit, where the gateway fits, where the Windows server sits. So this is very similar to how all that works, right? The sensors are the things, the fingertips, right? How are you getting data? What are the data points? What is it out there that you're gaining visibility into? But that data has to get somewhere, and that's where the network comes in, or the nervous system. It could be LoRa, it could be LTE, 5G, Wi-Fi. It could be wired at that point, right? It doesn't really matter, but that's what the transport layer is. But you have to be able to have something formal around how we're looking at this information and data. That's the architecture piece, right? Is understanding what the data is coming from, what the meanings are, that type of thing, right? What can I do with it? Where can it go? And then the cognition piece is taking all of that and formulating some analytics, something that's actionable, something that's real value to the business. And that's kind of the steps through this. It was very similar to what Kevin had showed, which is nice to have that frame of reference, because it shows the real parts and pieces of it. And this takes the little more conceptual aspect to it, because it can apply to any one of those.
And then obviously I said this right at the beginning, right? As soon as you expose data and digital information to your operating environment, there's a risk that it gets into the wrong hands. How do you approach the security angle of this?
Yeah, it really depends on where it's coming from, right? And how you can secure it. Ultimately, you want to secure it from the sensor all the way to that cognitive piece or what the application is at the full north end. So, I mean, it's a variety of things. It's how you're implementing the network, how the data is being moved around, and it's best again to have a singular approach to how all those things are secured because it makes management much easier, but it gives the opportunity to see how all of this works together. That visibility piece is huge, right? Understanding what devices are there and which ones are talking to who, because then you get an understanding of what's normal, what's not normal, so that you can say, oh, well, this device is now talking to this one and it shouldn't have been. So you were able to really drill into those things.
So
I don't
so
think you're getting much
visibility is
into
actually pretty
cybersecurity
key.
today, though, are you?
No, we're not going to dive deep into that in this segment. But um, question for you: you've talked to a few customers about this model. Where do people tend to get stuck, or what do they tend to forget about this model when they're figuring out what they need to do?
I mean, the biggest thing, like I mentioned earlier, is that everything is fragmented. So everybody's approach is different. So you have one group that may be looking at something that they already have baked in. Maybe they're using some other partner like an Emerson or Honeywell, so that's got its own little security wrapped around it. And then they say, oh, well, we need this other type of data from these other sources that we don't have connected. How do we now get that data? So they're all coming from a different angle. So that's why I said understanding what is all connected is huge, because it can be really complicated to be able to secure all this without saying, oh, we're air gapped. We're not connected to anything, which to me, I think is the biggest misnomer ever, is to say that you're fully air gapped, because we all know that people walk in with USB drives, whatever it is. Oh, I need more space here. I'm going to bring in my USB drive. I mean, all of these things just really complicate it. So that's not really a clear answer for a lot of these
Right.
individuals.
But it does allude to the idea that the information architecture component can actually be relatively complex, right? When you see it linearly like this on the screen, you're thinking, oh, well, I want that vibration monitor that Kevin talked about, and we're going to transport that data to somewhere, and then obviously there's a data model, there's transformation and stuff that happens there from like your milliamp sensor to whatever that actually means, and then you take that into the analytics and visualization part that you talk about your brain component there, right? So that is a relatively simple model, right? But what happens now when you want to actually pull some data from the historian, or you want to maybe even push data to the historian, or you want to pull weather data to tie into the model, or you want to access your ERP system to correlate with people who are on shift, or like there's so many different things you can do with that information architecture model. How do you make sure that you either don't miss stuff or that you overcomplicate this thing? Like, what's the guiding principle that kind of maps all this out for you?
I mean, that's all around the data governance aspect to
Okay.
understand what what the target is for the data that you have received. But the other thing is too, it's, we mentioned the boil the ocean aspect, and that's what you just did in about 15 seconds, is explaining all that, because that to me is part of that prioritization of project. Is, I mean, it could be a 2x2. So everything you
Right.
mentioned, you could probably put in a 2x2. So what's the um, time to impact? Excuse me, time to impact versus complexity level, right? So it's figuring out what is in that upper right hand corner, or however you want to do your timeline versus complexity, which one falls into shortest time to value and maybe the highest complexity that is in that realm, right? So
Right.
all of those things have been like integrating with an ERP system. That's a long time to value, right? But
Okay.
getting
Yeah.
some, it takes a while. It takes some, 15 years to implement them in the first place. But so getting some of this simple data is a short time to value. Being able to put something as easy, like I say, the vibration sensor. The nice thing about that is it's singular of purpose, but a huge amount of value. And you called out the great point about it, is we can have this simple vibration sensor out there giving us a nice baseline of what's happening. But then when there's an anomaly or something seems odd, then we can deploy the $2,000 Emerson vibration sensor to go out there and sit on the device now 24/7 to really get
Yeah.
an understanding of what's happening. So again, huge to me, that's hugely valuable. short time to value because you can deploy those sensors really quickly and have visibility almost instantaneously from when it gets out there. Obviously, the infrastructure has to be there, right? It doesn't just start showing up, but um, that time to value is a lot shorter.
Yeah, and I guess it has a fair bit to do with the value of the operation that you're monitoring too, right? I mean, if you're monitoring the vibration of a small water pump that's keeping the sump dry, is a little bit of a different deal than a large turbine that's like at the center of an operation, right?
Right.
So there's different scales to this as
And
well.
ideally, you're getting the data once, right?
Yeah.
So I might have 300 sensors. I want to get that data one time and use it as much as I can for operational things. Maybe there's business impact and supply chain. Maybe I'm using it for predictive analytics on some cases, but get the data one time, have it stored, have the architecture appropriately designed so that I can now just extract data as I need it.
Okay, so we're getting down another path here. Maybe we'll briefly visit this, right? So you say get the data once, but then there's lots of different stakeholders involved in actually using the data. Do you have some hints as to who owns what in an organization, or is that different in every organization? Because you'll have one group that says, yeah, we need this first, so we're going to go in first. How do they then make it available to other stakeholders without them becoming responsible for other people's level of success? And like, how does that work organizationally, or do you kind of throw up your hands at that point and say, you guys got to figure this out?
I think there's a couple answers to that. One of them, the easy button is that, like, you guys figure it out and let me know when you're done. But there's some other aspects to that. Is if you called out the historian, maybe everything's going there and you're getting it out. But the problem with the historian is that can't provide you real-time data, right? There is always a delay of some sort between when it's ingested and when you can output any kind of results or getting any kind of information out of it. So when it's real-time data that they're asking for, sometimes they have set up specific, I don't want to say data lake because I hate that phrase, but having some secondary or tertiary resource that's architected specifically for this type of visibility, right? So they'll set up it entirely separate. I know when I was at Cisco, there was a customer we worked with, they set up a tertiary network within their facilities to be able to get data out of the lower levels of operation. So they wanted temperature sensors, or they wanted, some things that was already being fed into the historian, but they couldn't wait for it. So they set up a separate network that was one way out to only extract data so that they didn't interfere with the PCN. So they'll go to a lot of lengths to make sure that they get the real-time data.
That's actually a really good call out. We're seeing that more and more often where the PCN environment is really kind of kept on its own. And a lot of these other data requirements are being driven like by the maintenance team, by the safety team, by the like there's all these other stakeholders that aren't necessarily part of the PCN world, but also need data, right?
Yeah.
And so a lot of times they end up their own infrastructure.
And I think by putting it in a single source like that, you can forego some of the ownership discussion, provided it's available on the terms that each specific stakeholder wants it, right? So as long as that's being met, I think it's okay on the ownership thing.
And I guess now a lot of organizations have like a data architect that actually drives a lot of that discussion.
Yeah, a lot of them have data scientists, data architects in their organizations already. What I was going to say is, you can't forget about the data ownership for the OEMs who want to own data from equipment also.
Oh, yeah, good point.
So that's always got to be a discussion to ensure that those, contracts, agreements, SOWs, whatever it is you're coming into contact with from an outside vendor, that they've worked through who owns the data, because that's something I know that comes up quite a lot.
Yeah. Yeah. Interesting. Yeah. Whether you're a well services company, or whether you're a turbine manufacturer, or who, like all these
or a
people
tractor manufacturer.
Yeah. Yeah, exactly. All right. Well, let's talk a little bit about kind of how this evolves, right? Because everybody kind of starts from zero. Maybe nobody starts from zero at this point, but we talked about starting simple. Maybe talk to people. I've got the Freeport McMoran story up on the screen here. Talk to me a little bit about how that evolved from starting with a really quite a simple project, and it evolved into a huge value for the company.
Yeah, and so I just the first call out. Obviously, this is not oil and gas, but the
Right.
fundamentals of this and how this works, and what was ultimately delivered applies, right? Because, like I mentioned, there's so much data being produced, and if it's not being analyzed, it's just data. So that's the foundation of this is what is it we're looking for, and then how can we apply it to those specific use cases. So they started by just putting up a mesh network because they wanted to have connectivity for whatever reason. I mean, it could be anything. It could have been accessing applications. It was trying to connect um, engine data is really what they wanted to do from trucks, right?
So
That
there's
was where
usually
it
some
really
kind of
based
anchor
with,
thing, right? Yeah.
right? And so it was just, focused on just one group that was looking for um, maintenance information on the engines of the haulers. They were able to get people together that were stakeholders that would understand the importance of it, and then they built this small use case around specific sensors and connectivity, right? And then they progressed through, okay, well, that's working. What can we do now? What's next? And then it began to expand to other assets within their organization. And excuse me. And what that ends up doing is it begins a roadmap, right? It went from just looking at engines, then they were looking at what they call batch truck snapping. It says, where is the truck on the road? So they can understand what the schedules are, how quickly it'll get to where it needs to be. They extended that to bad road analytics. So they were then putting sensors on the suspension. So the suspension amplitude would change. So they
Mm.
know that maybe the road's getting bad. So that they would preemptively dispatch their road crews to make sure that they were done appropriately. Traffic heat maps. I mean, it just exploded into this, what became a insight driven culture is what they called it, right? Because it was
Interesting.
data driven insights by all this connectivity and all the sensors, but they were able to use it and organize it in such a way that it really became impactful to the business.
Interesting. Yeah.
And
So
the
at
time
each
to
point
value,
along
I
the
mean, it's a
way,
long time, right? It was 9 years. But over that 9 year period, they were able to gain more than $300 million in benefit across the board. And that's across
wow.
everything, right? That's not just lost product. That's not just savings on, I mean, that's, everything that they were doing, being able to be more efficient, to be able to deliver more product. Um, and then they start getting creative with things like computer vision so that they can check on the crushers to make sure that they're doing what they're supposed to be. Um, on the big, I don't know what they're called. I'm not a mining person, but on the digging things, Bruce probably knows what they're called. The big digger things. They have titanium teeth on there because they could cut through the rock. Those titanium teeth sometimes break. Go ahead, Bruce.
Yeah, those are the shovels off of it, and the tooth metrics and everything else off of it. If one of those tooth goes in a crusher, it's so indestructible that it shuts down the crusher, and
Right.
it turns into a multi-million dollar mistake if a tooth makes it
Wow.
from the shovel to the truck to the crusher.
Yeah. So they were using computer vision to analyze the position of the seven, eight, nine, however many teeth are on it. And if one disappeared because it was part of that video analytics, they shut it down, and then we're going back, and they would manually, or however they would go through it, they'd go through the haulage to make sure that they found this before it went through the crusher. So
Right.
they've taken it to a huge level here to get a lot of benefits from it.
Interesting. Well,
And
I
this has
don't.
all been dashboarded. So they have people in the control centers that see all this that's happening. They have maps of the road. They see, where are the reds, the yellows, the greens, so they know either traffic or road condition. They're getting updates on haulage rates. Um, it's pretty interesting to see how it all comes out. And that haul truck operator scorecard was a big part of this as well. The red, green, yellows to say, oh, everything's in good shape. It's not in good shape, so they know how to address things.
Talk to us a little bit about that, right? Because I know WWT was involved in building that dashboard. What was WWT's role kind of in moving from that sort of first implementation, like through the journey? I don't know if you were involved in the initial step, but obviously you became involved as you went through it.
Yeah, so honest, I mean, it went through, just with basic data scientists looking at what data was available, how they wanted to start using it, and creating the analytics. And the analytics actually were initially performed in our ATC, before they could decide how they wanted to do it. Do they want to do it on-prem? Do they want to do it in the cloud? So we provided the resources for them to do that at the initial stages. But they've moved that into their own on-prem scenario now. It's increased in size from not only our involvement on the data scientists and the analytics piece, but also on their own, because we've also helped them to fish as they moved along to be able to understand how some of these things work. They've moved to Azure for some of these applications now, depending on what it is and what the data security needs are, and building out the AI and ML technologies with them to make sure that they're getting all the benefit they need.
So there's multiple steps to this. You do the analytics ahead of time to build the models, and then actually implementing dashboards around those models and everything. And
right, and it's like
obviously,
it's just getting it. I think the term we had used in the past was systemize it, right?
Right.
You have to make sure that it's done in a consistent and standard way so that multiple use cases can be built on it, because building some infrastructure like this for one use case does not pay out for anybody.
Right. So let's talk about, I mean, that's a really intriguing story. Maybe translate that a little bit into oil and gas world. Like, what kind of scenario do you see unfolding in an oil and gas scenario that would kind of follow that journey? Maybe if you took, maybe a refinery is a good example. I mean, we could go into any of the subverticals, but give me your best shot at kind of how that could unfold.
Yeah, I mean, I would prefer to look at something like the upstream scenarios, because there's so many other moving parts. It's disparate in location. If you look at some place like a Bakersfield area and how they do in the San Joaquin Valley, assets are pretty close together. So there's a lot of things that could be happening or impacting each other. And, one of the customers that we all know, they have about 8,000 wells in the San Joaquin Valley. So understanding how they are all fitting together and acting is good. But then you integrate the trucks driving around from place to place, plus the suppliers who are doing well-side chemical refills, tank level, all this could be factored into a single dashboard to understand how all these things are working together. And I think that's probably one of the best examples of it. The problem with I say problem, the thing with refineries is they have so much intelligence built into them already in some cases, right? They're running the Emersons, the Yokogawas, the Honeywells. They have so much insight built into what they're seeing already. It's not necessarily the ideal place to build some of these things.
Right.
Now, if you start integrating unplanned releases with weather data, personnel location, things like that, then you can really build something else that would be, I would say, worthy of that type of integration, because there's so many disparate data types, like you called out, right? How do I bring in data to this now? How do I move in? Where are my people located? How do I find out what asset? It could be a scissor lift, it could be forklifts, it could be anything like that, putting it all on a single map to see where it is.
Could also be a data integration piece too, right? Between the different systems. You're right that the people, the organizations you talked about, they're really good in their silos, right? But when you take, you've got maybe a specific process that's been automated with a particular PCN vendor, but then what about all of the water, right? Water management that's happening on site, or you take a look at power management that's happening on site, and those are all different systems, right? And yet there's dependencies at an operating level. How do you tie all of that together? There's some pretty important insights there too. So I think even though the complexity is there might be opportunity.
Oh, there's definitely opportunity. On the plant side, a lot of times it'll be in the TAR or the turnaround operations, because there's so many new moving parts there, right? You have a laydown yard that literally has thousands of pieces of equipment. Being able to integrate those things into an ERP solution, as well as your project management solution, like a P6, to understand, again, where people are, where are assets, how are we getting the specific tools to where they need to be. So again, data, putting it to a single purpose makes it much more valuable.
So one thing to maybe clarify here is, go ahead, Bruce.
I was going to say, I think that's a great point, Roland and Matthew, especially on the well pumps and the large areas, they're just now starting to scratch the surface on getting digitization off of that, looking at vibration, looking at pump pressure, looking at, there's still huge operators that are sending people around to drive around to take readings and put them on a piece of paper and then bring them back to the office. And then to be able to streamline that so that they can get better usage out of their assets. Not only do they get better equipment efficiency out of it, but the resale value on when you go from a tier 1 to a tier 2 to a tier 3 operator, the resale value off of that as you maintain the pump in a much better fashion is so significant that the operators are able to see a great return on investment. And then onto your point to the refineries, Roland, one of the things that we're seeing is in the larger tier 1 operators is the ability to look at the efficiency of refinery 1 versus refinery 2 versus refinery 3 and be able to baseline that, because up to this point you have each one with their own P&L, obviously, and each one is operating independently. But once you start to gather all of that data and digitize and be able to baseline it, you can say, okay, refinery 1 has got 5% more efficiency than refinery 2. What's different? What's going on there? And so it's a way for these larger tier 1 companies to really baseline across their huge assets.
Yeah, that correlation across the global companies especially can be tremendously helpful because, they'll have 20, 30, 50 locations, and to be able to understand how all those motors and pumps are behaving and the longevity and life cycles of those are all acting together, is of huge value.
Correlating with model numbers and all kinds of things, right? I mean, there's so much that can be done even for the more modern operating environments for sure. Well, thank you very much, Matt. We just kind of scratched the surface of what I know you'd love to have a conversation with customers and partners about. There's so much more that can be talked about. I know that you're also working on sort of some specific service offerings that you're kind of narrowing the focus on driving into market, and if certainly we'll be in touch and hopefully connect again in this kind of format. So thanks for your help.
Thanks, Roland. Appreciate it.
I should mention that that there's lots of pie to go around in terms of this kind of integration work, and I do know that there's other integrators that are on the line here as well that do good work and have data science groups and that kind of thing, and so I would just encourage operators to take a look around, right? The message here from Matt is listen, you don't have to do it all yourself, right? And I think that's really, really key is bring in people who can help walk you through it. Even if you have all the smarts in-house, it's sometimes helpful to walk with someone through the process.
Yeah, it's just the scalability aspect, honestly, right? I mean, all the customers that come in contact, again, not to take this too long, but they know what they generally want to do. They generally have an idea of how to get there, but they just either need a little push, they need a little help, right? And augmenting that in a way that you're teaching them to fish, I think is the most ideal way to do it.
Yeah, that's awesome. Yeah, I love that.
That was Matt Nalbone, who helped us map out the elements of a database solution to deliver insights from a wide collection of data available to us. You can jump right into the next session of our Virtual Energy Summit by clicking on the next video. Take care.